this to be the laboratory. And once we're in the laboratory, everything is considered a chemical, even water. I mean, water is always a chemical, but once it's in the lab, it's a chemical, and we don't eat chemicals. So we are not going to eat marshmallows before you ask me. But what we are going to do is a little bit of work with pressure. You just put pressure into the balloon to pick the cup up. You put air into the balloon to create pressure to pick the cup up. I am going to take air out of this jar. And I'm going to do that using a vacuum. The vacuum is going to take air out. I almost said the vacuum is going to suck air out. But here's a rule in science. In science, you cannot suck. What? It doesn't exist. You can push and you can pull. So I'm going to use this vacuum to pull the air out of this container. Why is it really, really thick glass? And I'll show you how thick it is. Whoops, and I lost my marshmallows. Why is this glass so thick? What do you think?
So it doesn't break.
Exactly, because as I am pulling air out of this glass, there's still air on the outside pressing in. And if this glass wasn't very thick, that air would be strong enough to break my glass. So instead, I have very strong glass. I might actually need a little bit more Vaseline. We'll see. We want a good seal, because if air is coming in as I'm pulling air out, we won't create a vacuum. All right, Miss Jack, you can stop talking, right? We want to see what's going to happen. So as I pull air out of here, what do you predict is going to happen? Scientists make guesses. They call them predictions, because in science we have a fancy word for everything. Who has a prediction of what's going to happen to the marshmallows? What do you think? What do you think will happen to the marshmallows as we pull the air out of this vessel? Do you have a guess? Do you think they'll get smaller?
Yeah, that's what I was going to say.
You think they're going to get smaller?
No.
Raise your hand if you think they're going to get smaller. Raise your hand if you think they're going to get bigger. Raise your hand if you think they're going to catch on fire. Oh. No! All right. Are we ready? Oh, raise your hand if you think we're going to stay the same.
What about if they're going to explode?
Whoops.
That would be getting bigger, though.
I wish
If they're going to explode, they'll be getting bigger.
No, it didn't suddenly.
Watch.
Keep an eye on the marshmallows.
Oh yeah, it's squishing. It's squishing.
Look at the one on the outside.
The one on the outside is sitting in normal air. The ones in the jar are under vacuum.
Under vacuum or salt. It's a vacuum or salt. Crank it up higher.
See if this is actually doing anything. I'm not sure it is. There we go. Do you see him shrink back down? Let's see if we can get a better vac. I think the problem is my Vaseline. Unfortunately, in science, of course, because he's videoing it, not everything works the first time. Mr. Steve, we might be ready for your
Okay,
hand
so while you're
over there.
Vaseline. Alright. So another thing we can see when we are creating vacuums. Okay, so in this pot, we have some ice water. It's really, really cold. Here we have some water inside these cans that is boiling. So what happens when water boils? It's hot. What happens when water gets hot?
It turns into a gas.
Turns into a gas. It starts turning into water vapor. We can see the little droplets coming up that's in the water vapor. Because remember, can we see gas?
No.
Okay. So we're going to try to get this to work. Now what do you think is going to happen?
Remember, flip your hand the other
Yeah.
way. We were practicing this earlier because I failed this one a
Yeah.
lot.
So what do you think is going to happen when I put this can into the water? What do you think is going to happen?
Just tons of steam's gonna come up and.
Okay, so we get lots of steam. What do you think?
I don't know if this is only with glass, but doesn't it kind of break or?
So you think it might break? Okay,
That
but
is true.
glass does break when it goes from being really hot to being really cold.
Yeah.
Okay.
Might.
Any other ideas? Okay. And
I'd
let's-
go with him.
Okay. Let's see if we can get this. Oh.
3, 2, 1. Oh, show
Oh.
what happened. Did it explode?
Not quite.
I think something like that would happen.
Okay.
Let's try it with the plastic.
Well, let's see if we can get. Uh-oh. Let's see if we can get it with the other.
Claire, let's try it in here so they can see it.
Okay. Let's see if this works. This is the first time. Okay. And
Woo! I just saw a spark.
was there? Okay. So what happens here? When water boils, we said that we created water vapor, right? Now when that water vapor is created, what do you think it does to the air inside the can?
It takes it out.
It forces, it pushes, since we only push and pull in science, it pushes the air out. So the can is filled with water vapor. And then when we submerge it in the cold water, okay, it starts condensing down again from that water vapor into air. Sorry, into water. Yeah.
It's okay. At the end of the day, all the words sound the
Yeah.
same.
It goes from being that water vapor down into being a liquid again. But when that happens, is there air in there to take the place? No. So we're creating a partial vacuum. And nature doesn't like for there to be vacuums. So as a result, the can pushes in on itself. The pressure is trying to match up.
So that's-
That's what would happen to my glass jar
Yeah.
if it wasn't very thick, because all that air pressure outside is too much. The can isn't strong enough, but my glass jar is. So now that we have a better seal, let's try this again. Keep an eye on the marshmallows.
It's not happening.
Yes, it is.
Oh, you threw it back to explode. See, that's how we get bigger. So that's how you make it. Whoa!
Should I do that again?
Yeah.
Alright, right now the air is being taken out. Because marshmallows are a lot of air, they now have more room to expand. There's not as much pressure in there. And as soon as I let the air back in, they shrink back to normal size because that air is putting pressure back down on